Mohammed, can you let everyone waiting in the lobby in, okay? And number of attendees. All right, okay, just 12 o'clock. Good afternoon, everyone. My name is Nazmi Salami. I'm Associate Professor Mechanical Engineering at Edinburgh Napier University. And I'm happy today to chair this webinar about our research project, HI-SCOT. HI-SCOT project webinar called Heritage Meets Energy Innovation, Smart PV for Historic Buildings. So in our webinar today, we have two presenters I'm going to introduce, and our research project is supported by three partners from non-academic partners. The first one is CeeD, Centre of Engineering, Education and Development. The second one is BEFS, is Built Environment Forum Scotland. And finally, Dat Al-Arqam, which is like a heritage building. We work with them as a case study. Today, in today's webinar, I will be joined by my two colleagues, Dr. Firdaus Mohammed Soki and Dr. Mohammed Chiza. They will help me moderating this webinar, and they will be helping also liaising your questions. So just to let everyone know, if you have any question, please do not hesitate to pop them on the chat box. And if you want to ask your question orally, let us know as well. We can mute your microphone. Also, this meeting is actually recorded, and we hope we can share it later on our platforms. Please, if you have any issue or consent that you don't want this to be shared, because your names, they appear here on the chat and the people attending, please let us know, and we do our best to hide your details. So today, as I said, it's a webinar is to do with our project HI-SCOT. It's a current project actually in collaboration with Robert Gordon University, as you can see here, and funded by Scotland Beyond Net Zero. As the name refers to, is looking for what is going to happen beyond net zero. So as a project, we are looking at the different aspects, all aspects, mainly policy, technical aspects, environmental, of adopting PV panels into heritage buildings, which is something Scotland is known for. So we want these buildings to not be excluded from all this trend of decarbonization. And that was this project looking at. So at the webinar today, we aim to share this finding in this approach of HI-SCOT, looking at achieving this, decarbonizing this heritage building with PV mainly as a renewable energy solution. We're going to highlight in this webinar, we're trying to highlight the technical, the policy and social challenges into this. And you're going to show some, showcase some innovation design and material into this. And part of this project, we're going to encourage discussions. That's why we rely on our two highly profiled presenters and you guys to encourage the discussion and about all these aspects. And we are welcome any question and hope we have a really good discussion. So today webinar program, we have two presentation and two presenters. I know previously it was scheduled for three, but one of the speakers or presenters had like unforeseen family circumstances. I could not attend today, but we are happy here to welcome Professor Amar Bennadji. So he's an ex-colleague, and I'm really happy to welcome here today. He's from the Hanze University of Applied Sciences in Groningen in Netherlands. I hope I pronounced it correct, but I'm sure he will pronounce it correctly later. He's going to present today about retrofitting heritage building with BIPV, design challenges, opportunities, and case studies. And our second guest speaker is Professor Hatem Mahmoud from Egypt, Japan University of Science and Technology. And today is going to present from a title about towards standardized digital workflow for heritage building modeling, integrating surveying, validation, and multi-objective application contributions. So this time here is advisory. So normally each presentation will take half an hour or more. But because today we have only 2 presentations instead of 3, so we have like time to extend the discussion for each of the presentation. So without any further delay, I'm happy here to welcome Professor Amar Bennadji and ask him to start sharing his slides. And when he's ready, he can start his talk. Professor Amar.
Hello everyone. Goedemiddag allemaal, which is hello everyone, or good afternoon everyone in Dutch. My name is Amar Bennadji. I'm a professor of sustainable built environment at Hanze University of Applied Sciences in Groningen, in Netherlands, which is about 2 hours north of Amsterdam. And I have been in RGU for over 2 decades. And I'm happy to be speaking at this event and debate this very interesting topic related to the adoption of solar panels in heritage buildings. My presentation is as follows. First of all, I would like to have, because I don't know the background of the audience, so I try to have small definitions of what is retrofitting, what is heritage buildings, what is integrating photovoltaic systems in buildings, and then what that means for heritage buildings. And then on the second part of the presentation, there will be the discussion of the design challenges, the opportunities and case studies. And it won't be in chronological order for the last 3 bits because there will be challenges in different case studies. So there will be back and forth towards these three aspects. I would like to present my professorship, my research group, and this is a business card that I developed with an artist where we do research on bio-based material and geo-based material, innovative materials in terms of, let's say, insulation using natural material. Circular economy is a huge part of the research group where we reuse existing buildings, components to develop digital logbooks. So this is part of digitalization of the built environment. And designing for dismantling is an aspect that we look after. And look after new buildings as well as existing buildings, rehabilitation and so on. Solar panels, integration solar panels into buildings is very important to the point that if I give you the chronology of how this business card was developed 3 years ago, there's a small drawing I supplied to the artist, and then we had 3, 4, 5 illustrations, and then you can see that before the end, the solar panel that's in the roof there, I negotiated with the artist that I don't want them to be there, kind of clear color. And the last illustration can show that the solar panels kind of visually disappeared, aesthetically speaking, and this is just in relation to today's topic. Few definition, what is retrofitting existing buildings consist of. When you say existing building without touching necessarily the heritage, And it's, in short definition, adding new features or systems, which could be replacing windows or fenestrations, insulating walls, adding systems, which could be ventilation, PV, and so on. So this is, as a starting point, what is the retrofitting. And it could be something like that. Without talking about aesthetic, or it's about, technically speaking, correct. Things can work together fine, and is fine, is done by many. This is a real case. But the debate that we will have today is about the integration, and as an architect, I'm mainly interested on the aesthetic part, that was, by the way, developed by Samuel, that was part of the project. Then you go to heritage building. When you talk about heritage buildings, they are buildings that have a value for a community, for government, and this imply the implementation of legal protection, trigger some laws, and control what can be done and what cannot be done. And what can be done and what cannot be done is something that is to be debated, because if I give you an example of the windmill that we have in Netherlands, they are now a feature. They are part of the landscape. Everyone liked them, but when they started, they were rejected by the population. This is something that need to be debated. And when you talk about these heritage buildings, it could be as small as a cottage, which is Le Corbusier's. If you don't know them, if you are not architect, maybe not necessarily, which is a small cottage. It's listed building, and it can go to complex buildings in the heart of some cities, where the shape is. Anyway, building is listed because it's interesting for the community, the country, and so on. And can go to castles, and this is, I don't know many from Aberdeen, but this is well known. All these are could be heritage, built heritage. We have even, in part of my professorship, we look at heritage building, and there are some buildings that are hidden, call it hidden heritage. There was excavation and then identification of building and so on, scanned and so on, and then they recovered them, and we think that is the best way for some building to be protected and preserved for future generation somehow. And now we talk about building integrated photovoltaic in heritage buildings, and this is the critical question, and the definition is that integrating component without compromising historical and architecture value, meaning that the building should be kept as original, as authentic as possible. Because I'm an architect, I have to give you some examples. This is a heritage building. It could be very, very challenging to have such addition to an existing building without really having a discussion and debate socially and so on. But it was done, and I would say you can share your vision on the chat, but there was a clear integration, discussion between history and modernity, and the architect managed to have a separation between the two, and you can debate that further. But talking about solar panels at the scale of the facade or roof is something, But here, it's really a bold action on the site, and some like it, some don't. But this is a starting point, so the rest might be easy for you to digest. At a small scale, when you talk about challenges and so on, and integration, heat pumps are becoming more and more popular. This is not necessarily a heritage building, but it could be. And we can see that the owners try to hide, maybe it's in the back of their house, but they don't like it, visually speaking, and they covered it. Okay, it's an attempt. Yeah, why not? And sometime where the space is not there, the heat pump are installed on top of the building. Some are handmade, which is just steel that are folded around the heat pump. Some are more manufactured and different shape, form, and so on. They start to grow like mushrooms in many roofs around here and around Europe as well. So these are normal buildings, but the case could be for built heritage. The retrofitting can in the old version of the building, you might see that the solar panels is odd because the building has a character, I would say, run down. But the new version of the building retrofitted, everything came together, and I would say that the solar panels here are more accepted on the new version, the retrofitted building, than the old one. Just because of architecture touch, decoration make a difference, and now there are studies who can measure the taste and the impact of building on people, and yeah, it's the taste and is measurable. If you go through all the retrofitting aspect of buildings, many of them, and the legislation has improved since, we can see that it's not really clear, but insulating the roof, for example, could be in terms of they say for the building could be low or medium, and so on. But when we go to the solar panel, the wording is potentially yes, and then on the rear of or the side of the roof. This is the discussion that some councils has outcome from paper, what can be done or cannot be done. All aspects you can see usually, rarely, and so on, but potentially, and this is kind of potentially for what reason? What's behind it? Is it measurable? Why is it yes? Why is not? And so on. Yeah. So if we raise just a few challenges, we can talk about the aesthetic. For me, it's the most important due to my background, and then the regulation that follow the aesthetic. I mean, we influence the policies and so on, but when you talk about aesthetic, this is quite challenging. Talking about the structure, old building, historic building, if you talk about the roof, they have this roof that have been, let's say the structure is as it is. We don't know if the structure will hold more weight, and so on. If you talk about the material, going to see the materials in some few details, in terms of colors, in terms of texture, and so on. And then another challenge is how we can, when we deal with the heritage building, we can create a model to visualize how the building will be, how true is the screen, computer screen is showing the different colors, and how the decision is made to say, okay, we go with that, it's fine. But then when everything is done, it's not really pleasant. Let's go with easy part. When you talk about heritage buildings, we talk about heritage as a built environment. And when you talk built environment, is not only buildings, the built environment is also spaces and so on. And the definition of even landscape architect is part of the built environment. A case like that where roofs are not welcoming solar panels, a sculpture like that, which could be seen as a good example or bad example, having a peaceful space where an alien invading it, steel structure, they try to have leaves and so on. Is it welcome? No. It's debatable. Could be a nice feature for some time. It could be a representation. It could be easy in kind of the general public to accept innovation. And if you go to another extreme, a building, this is the Fontainebleau Hotel in Quebec, and it's part of the heritage there. It's kind of castle. Is it an opportunity? Because there is my thoughts as opportunity. Is it something to be kept as it is? But I would say the more, if I give you the example of the same building where I just applied changes on the roofs and the with color schemes. If you don't pay close attention, I made it a bit highlighted to see you might say it's the same thing. There is no changes. So the design is about what you have, how you can adapt colors, how you can integrate these solar panels to be visually acceptable, because you talk about visual pollution as well. I think the more is chaotic in terms of color scheme, the more chance you have to be, your design can be accepted and so on. If you take example of Edinburgh, I didn't know that there is no solar panels on the roofs, but this is shared in your in the project. And if we would like to adopt solar panel there, we might need to have a kind of color scheme. Like I put a little touch to say, okay, between this and this, you might say, okay, it could be, okay, we can just tone a bit lighter color to be accepted. But the shock is if the solar panel are black, and I avoid the shock for a long time. But this is how the discussion on how to preserve the look of the built heritage before talking about the materials and so on. There are other challenges that relate to the structure itself, the support of them. Altering or we have a fixing system to the roof. If it's a historic building, we don't know how safe it is to really go deeper into from the top tiles, or this is not tile, but it's a softer material. In some cases, there was water dripping, and maintenance is continuous. Light structure, sometimes the wind even can blow them out. So this is an aspect of, without talking about the color, but it's a challenge on how the components are linked to the building. The industry developed a lot of systems. They are not designed with the building initially, so there will be a kind of movement on the roof itself, and movement as a consequence, you can have part of the structure broken. Tiles can break. The timber structure can be weakened. You can see here 3 screws already on a timber button that doesn't really look kind of very fresh, which could be seriously damaged. We have many suppliers of these solar panels, manufacturers, as well as fixing systems. Recently, Europe adopted kind of same mobile phone charger to have to avoid this varieties. But what about all these fixing systems? Sometime between, for example, the MC20 and MC27 was 7 millimeters difference and so on. This is just part of it. It's a challenge because if you would like to change a panel for some reason, sometimes the conductivity, are sometimes mounted in series or parallel, and one panel doesn't work to replace it, and have the system can be different. So these are part of the challenges. The others is also in the application. In many cases, we saw solar panel installed on roofs, and you can see that the roof is not ready. Even you can see fungus growing on the roof. It could be worse in few years. Solar panels have lifespan 20-25 years, and the roof could be at least let's say improved, but there is a hurry to adopt solar PV in existing buildings, and the roof is maybe the time to change it is closer and so on. So it is sometimes a step that homeowners or buildings of certain character are ignoring that. The movement of also the system that to place the rail, we need to remove the tiles, remove it or push it up, or depend on the type of tiles, how they are fixed. In that movement, there is a statistic of a small percentage, but of the tiles broken because of this movement. The system, there are different systems that goes inside the behind the tiles, on top of the tiles. Are they linked to the tile themselves or to the structure behind it? If you have, let's say, a membrane there, it could be broken to go to the structure, and sometimes they're not repaired, which means moisture, water ingress, and damaging the insulation and the timber and so on. It's quite serious consequences if it's not done properly. And as a challenge, what can we do for such building? They are quite abundant in the Netherlands, part of the UK as well, and the rest of Europe. If you don't have a garden where you can put your solar panels, and you have a listed building, this is not one, but similar there are, how to install the solar panels. Generally, the depth is quite 20 centimeters, and then it is a challenging thing. The structural aspect is also challenging. The solar panels have a certain weight. The industry is trying to reduce the weight, and sometimes the more advanced ones are heavier. You can see that in some examples. So the collapse of a whole roof, and these panels are for the residential one. They are about 20 kilograms. It was easy to hold it, and for some others quite heavy. And the industry is developing quite light panels, softer, flexible. But how to apply them on the roofs? If you see sometimes they cannot be fixed to the roof with the wind. So it's quite difficult to apply this system on certain roofs unless it's really the integration is really well done. They can be as light as 0.4 kilograms for a small panel of about 200 watts capacity. The other challenge is also the fire. we have heritage building that we would like to preserve, and then we install solar PV and catch fire. The fire can damage the whole building. In some countries, I think the UK is still the case, the fire brigade can't attend. Let you know if it's still the case, but it is a challenging. It's like you let the building burning because of health and safety of the fire brigade and so on. If we contextualize this in the Netherlands, there was a quite fast growth of the use of solar PV in the Netherlands, and the regulation, I mean, the start to can be softer in terms of adapting them in historic buildings. And yeah, the aim is that this monument will participate in reducing CO2 emission, and the National Heritage Council relaxed some legislation, and they make them, I mean, making this building more contributing towards tackling climate change is the reason behind it. And developed a lot of guidelines. Visually, we can see that, for example, certain point, the solar panels could be installed in the back of a building or side of the building, not at the entrance to really don't be seen from the entrance. Unlike normal domestic building where they are allowed in flat roofs and in hidden part of the building. This comes under the Sustainable Heritage Route Plan. So to make them more sustainable, reducing their energy consumption, so the adoption of solar PV become more and more accepted by the agency that look after heritage buildings. I would like to go through a few examples, but this is the same time, it's a critical, I won't just say this is fantastic, go for that. I'll prefer to be more critical and say, why not another solution? This is, I don't know if you're all professionals or students or architects or engineers, but the presentation will be kind of in term of form of debate, what was done and how it could be done better. To don't say they are not good, but could be better. This is a case where the solar panel was implemented on the roof of the building. The roof, for people know, it doesn't look like a great roof, and solar panels might be, the roof is not a long life type of roof. And if you see the shadow, because I don't know the location exactly, but following the shadow, you can see that there is a possibility. For example, here, these are the elevations. So this is view from the top. You see the elevations, a nice building. It's currently listed. But you can see that with the angle that we saw, there is a part of the top floor that could adopt solar PV, and I just altered a bit where the solar panel could be, and you can see that between these two views, you might accept that, okay, they are more or less the same, and if we put solar panel there, and you can even have the vertical lines there, part of the solar panels. So this could be a solution, because here there will be a lot of maintenance for the roof needed. So yeah, why not add in that? Because the building quite huge, and the energy needed might be high. Go to another part of this is in Spain. It's a church. Okay, dual color, red, terracotta, and white. Sometimes I would say my point of view is that the building has been even embellished by these solar panels. It's quite covering the whole roof. It's not patchy, and it's done well, so fine. Covering the whole roof sometimes is better than partly, because there are some regulation where you are not allowed to reach the edge of the roof, and you need to be about 30-40 centimeters for the edge. They have their reasons, but in other cases it works, and it's fine. In Switzerland, this facade, for example, of a building, taken as a case for modern building, the solar panels are multicolors. It could be one color, it could be boring, but you can see that the architects adopted different colors, make the building more interesting. And this reminds me Balamori in the UK, and in the two pictures I changed a bit of the walls, not the roof, and you can say that because also multicolors, you can add to it, adapt the same color of let's say the orange. I put a panel there, big one, on the top picture. And even if you have more colors that are different than what you have there, or similar or totally different, it can still be blended in. Solar panel could be blended in the facade and socially accepted, I would say. Go to another part of this is in Australia, and it's again a church with the Gothic style, completed nearly 160 years ago, and renovated 25 years ago. In this building, because you talk about opportunities, the opportunities for this building is to reduce the CO2 emission in the over 35 years, with equivalent of 57 barrels of oil, and the payback period is less than 10 years. 10 years is good for payback period. So this is an opportunity for this building, and other buildings have the same opportunities, and sometimes it's a very valid reason to retrofit building with solar panels. The structure is here, it's more glass and heavier than the previous one we saw. It's because of the structure, heavy weight of the glass, they needed to have another structure. And for me, let's say also be critical. It's heavy structure, okay, but it's a listed building. It's a church, 160 years old. Having a metallic structure, some would say, okay. For me, I would say maybe if you'd like to preserve it, let's play something else. And I just illustrated the passage here between the two buildings or the church. The structure could be okay, need to be tested first, but you could have avoided all this metallic structure and having it just resting on the wall on top, fix it to the wall internally or on top, or crossing the two buildings edges. Don't know what the support is there, but I would say that this is too much as addition for the roof. They adopted dark color maybe to blend it, but it's my point of view. By the way, because Nazmi, because you said that you told me an hour ago that you don't have the third speaker, I added a few slides just to use the time.
Sure.
Yeah. Okay. Yeah, this is a town hall. Externally, it was not touched, but internally is also a kind of heritage building. We can see it on the top is done, it's kind of sleek, it's clean, down, and so on. But internally, we have a different structure, and it's quite busy. We have a cabling system, we have a tube to support, it's a heavy structure, but it's also a building is also seen from inside. It's not just outside, from inside. And for me, this is quite disturbing. And we could maybe adopt another solution, which could be even instead of the cabling, have metallic working tension, but metallic same color scheme to just to have one color light, and the system could work better. So it's about design. That's what the challenge is, not only about material, color, so on. It's also about design, how, and when you talk about design, we talk about case by case, and it might be difficult, I don't know, at the end of the project aim to say we need to do this and this and this. We should leave maybe part to say it's a case by case. Go to the Netherlands case study where it used to be an old rice house adopted to then change it to other functions. This is an illustration by architect to have a discussion with the building owners or local authorities. There was few color schemes. We can see that the black dome is quite a calling point, is kind of attracting all the attention, is kind of a heavy point there. What happened on the roof could be nearly everything, since you have a kind of quite a strong point in the building. Some architect might understand me. And then this is the suggestion of having solar panels on the roof. Is it good? Is it not? But the final result was something different. You can see that the color is lighter than the previous one. And at an angle, if you don't concentrate, you don't see really that solar panel have been added to the roof. So there is kind of a good integration to the two. The calling point, the black for me, and at a distance in the park, for someone who used to visit the park, you can see that there is no change and so on. So it doesn't affect, quite well blended. In go to the smallest scale, light touches. Sometimes we say the devil is in the detail. It could be listed building or not. I don't know about this one exactly, but I know that in some cities the balconies are listed, the facades and so on. And small touches like that, where the solar panel is not the conventional 160 by 99 centimeters and so on. Solar panels now come in different shapes, and they can be also designed for the specific site. And I would say a balcony with 2 solar panels like that, they can be even for listed building. If it's not richly decorated in the back, we can even be decorated, and can refer you to Samuel's PhD, where there was kind of decoration on the panel itself. If behind it there was kind of more artistic metallic work, curvy and so on, this can be adapted on the panels as well. Colors, the roof, original roof, or the new roof, this is they call it the largest. Okay. And they didn't do it black, it's red like the other, but it put it still in the back of the building. But colors are coming more and more popular, and they also now can have matte color. So this is a solution. That's kind of last few slides here. Green roof is more popular, but having solar panel instead with the color scheme. Tiles, for example, there are some another roofs. They are not in the original tiles, but there are tiles on top of the original tiles, and the shape, color are the same. The way how you design the roof with solar panel on the roof is also reached. And now with multitude color schemes, you can adapt color that suits your design. And for Edinburgh, because I shocked you with the black spots on the roof earlier, because of scheme color, these possibilities of having lighter color, and then you can change it to be really close to what you are looking for. And finally, as a conclusion, I would say that while the solar PV technology is advancing, the major part lies into the design solution for specific heritage buildings. And this need to be addressed case by case as a recommendation. And we need legislation that can understand this aspect, so that at a certain point it's forbidden to use them in front of a heritage building. Things are changing now, and the legislation need they are inspired by from a recommendation by researchers and interviews and questionnaire to general public and so on. And on top of that, the skills are still to be developed. I know that in general for retrofitting buildings in the UK, in the Netherlands, we require about 600 new skilled building on all retrofitting aspect, but looking at solar panel installation and so on, this need to be developed, and this without that we can't go beyond net zero. Finally, thank you very much for your attention, and looking forward for any debate. Thank you.
Thank you so much, Professor Amar, for this informative presentation. Actually, I learned a lot actually of those new technology and the way they install into buildings, and it's good to see that perspective of from an architect actually talking about the aesthetics, the colors and stuff like that. That's really informative. Thank you so much. Thank you.
You're welcome.
We are open now to question. As I said, I informed earlier, if you have any question, you can let us know. We can unmute your microphone, but we already received here 3 questions, Amar. So I will just go through them, and so you can refer to them on the Q&A box. So the first one from Sophia Amar said, if you were to rank the challenges involved in installing solar PV on heritage buildings, what would you consider the most important factor to gain approval for installations? I think you are muted, Professor.
You're muted. Okay.
No, you're still muted, Ammar.
Could you say the question, please, again?
Sure, yeah. If you were to rank the different challenges involved in installing solar PV on heritage buildings, what would you consider the most important factor to gain approval for installations?
Yeah, it is a serious question, and I might have an answer and then another answer after. I would say the most challenging how invasive is the solution to the building. and when you say invasive, this include aesthetic, technical, and sometimes even thinking forward how the building is reacting in 10, 15 years. So I would say that the invasive, how invasive is the building? This is the most important part.
Do you think these challenges, I mean, following on this question, they will vary depending on the geographical location? Since I know you have the experience between like now Scotland and Netherlands.
It's not about geography. It's about the integration, and even if you take this in the same city, 2, 3, 4 buildings, and one solution could suit one building but not another. It's about the design, and then when you say design, it's really having the right eyes that see the building and the value of the heritage building and how this new solution will, because in the worst scenario, someone will say, okay, we can put solar panels 20 miles away and serve the building. This could be the radical one when it's really impossible. But if you'd like to take it case by case, how and the need of this building to be part of the climate change discussion, and the building, as in the Dutch recommendation that this building should be part of the tackling built environment climate change. The design is the most challenging part. And when you say design, there are different layers in the design. So it's case by case.
Thank you. Thank you. We have a second question from Mario. He said, thank you for your presentation, Amar. So why you formed your table near the beginning of the slideshow explaining the likelihood of different retrofit measures, typically being given planning permission in heritage buildings?
Mm-hmm.
So what informed your table near the beginning of the slideshow, explaining the likelihood of the different retrofit measures typically being given?
This taken from, and I said we moved from that time. We said we moved. The title was we moved from this table. It used to be the case where it's not strictly. I mean the last part of the table, it's rarely, potentially, and so on. This used to be the case, and now it's more straightforward. And yeah, that's why I put the title. We moved from this comments now. It used to be kind of as a recommendation to say, yeah, this is possible, could be, but now it's more straightforward.
Thank you. Thank you. Another question from Ehsan here. He said, thank you for your great presentation. He has a question, said, what technical and regulatory barriers most often limit solar PV adoption in listed building based on your experience? And how do you deal with it?
From the recommend, yeah, if you talk about the Netherlands, because it's there was in the last 20 years more debate and less restriction. The planner we have a guidelines in the picture the table that I show. So technically speaking, it's visually speaking, is accepted, but then go into the details, the technical details, how to implement them, how to fix them. I won't be the best person to answer that, because I don't know how technically the building will be surveyed and assessed and approved, and so on. we don't look at this aspect in details. I hope I answered this question. Yeah, sorry for that.
Yeah. No, it's all right. I have another quick question now. So regarding the like a planning permission for a PV installation on heritage building, we have different players. So we have the council, we have the owners, we have the neighbors or the people who are really trying to conserve these buildings, and we have the architects. What do you think here the main player that should play the role here to move this forward and promote these installation?
Yeah. In one of the slides, I said that the Gementa, the municipality was given more power on giving planning permission, but in serious cases go to the Heritage Commission, who are very strict. And I would say the designer again could be architect and or team of designer to choose a solution. They are the most important. How they convince the municipality and the heritage department, because to be honest, although the municipality is quite soft in giving approval, in some cases the heritage department try to be, I would say, to be quite difficult, and this is valid for not only for solar panels. If you build even an extension or you do something to your building, you need to convince the planner. The planner should be able to, by looking at the plan, to say, okay, this is feasible or no, but not writing me pages to convince me that this is the best solution. So that means the effort should come from the designer, architect or so, and convince the authority that what I did is the best for the building.
Thank you. I mean, just maybe one question to summarize this. If we say in one rule, in one sentence, if you want to install PV panels on heritage building, we should do what we should really look at. I mean, for someone is trying to start this kind of projects. Is it the aesthetic, the structure, is the I don't know how valuable
There are
is
many,
the building?
Yeah, I think it's if you talk about aesthetic, there is the aesthetic part should be because the definition, if you work by the rule, the division is that the solar panel won't affect the appearance of the building, and that's why the case study that I showed and I kind of color things is that the solar panel, sorry, won't alter the building that much. But then we saw the roof collapsing, fixing issues and so on. Testing, having the test by structural engineer, how technically looking at the details, how technically the solar panel will be installed. And this is again valid not only for solar panel, for anything that you add to a building or even in your building, looking at the details, how things will happen is part of the design, because there is the artistic impression that I have from my professorship was colors, but we didn't go see how things are fixed. So there is a technical side, architect technologies and so on, to see how the details will be done. And then on top of that, training people to do it. And because historic buildings are different, the construction are different, the skilled person should be able to jump between a case and another easily and find maybe a solution that is in situ solution, because once you open a building, you might get a surprise, and what you learn on other cases might inform you on how to adapt it to the new case. So it's a complex situation, but it's not only aesthetic, although I concentrated on the aesthetic now, but it's also technical, structure and technical.
Thank you so much. I think we finished with the question. I would like to thank you again, Professor
You're
Amar,
welcome.
for your great contribution and
Thank you.
helping with this presentation. So it was really good. So I invite
Thank you very
everyone,
much.
if you have any question, you can always share it with Professor Amar. I think he shared his email address, and we look forward for a future collaboration and presentation. Thank you so much, Professor
Thank you,
Amar.
everyone. And as I said in the conclusion, that it's a through discussion that we can reach solutions. What I said is partly what I feel is, but together we can go beyond net zero. Thank you.
Thank you so much. Now, I would like to welcome our second presenter, Professor Hatem Mahmoud from Egypt-Japan University of Science and Technology. Professor Hatem, can you hear me? Professor
Hello.
Hello. Okay, welcome, salam. Professor Hatem, if I can ask you to start sharing your
Yes, I can hear you well. Okay.
Yeah, if you start sharing your slides.
Okay. Now I will
So
share.
Professor Hatem Mahmoud will be presenting his talk about towards a standardized digital workflow for heritage building modeling. So it's different aspects related to heritage building here from standardized digital workflow. And he's going to focus on integrating surveying, validation, and multi-objective application contribution. So the same will apply here, guys. Please do not hesitate to put your question on the chat box, and we'll be happy to go through them. We're just waiting for the slides to come through, Professor Hatem.
Is it clear now? I already shared.
No, we can't see them yet. If you try to...
Really? Okay, I will try.
There you go. Yeah, now we can see them. Oh, they're gone again.
Again, sorry.
That's all right. Try to move to the next slide, what you did earlier.
Hello?
Hello?
Yes, sorry, the connection is...
It's okay.
Okay, I will try now.
Try again, and in the meantime, if you'd like to send us your presentation, we can share it from here. So if that helps.
Okay, last try.
Yeah.
Now?
Yes, we can see it. That's good. And we can see, okay, last try. So it's fine. I think it detects your...
Okay, now it's okay?
transcript. Yeah, all good. So Professor Hatem, when you are ready, if you would like to...
Yes, I am ready now. Okay, and start.
Okay.
Okay,
Yeah.
first of all, I would like to thank the organizer for this invitation and for giving me the opportunity to share our recent work in Sustainable Architecture Department in Egypt-Japan University of Science and Technology. Also, I would like to thank Professor Ammar for his presentation. It's a really impressive presentation and covered a wide range of architectural aspects and the challenge for installing BV on the heritage. Thank you very much. My presentation today is entitled Towards a Standardized Digital Workflow for Heritage Building Modeling. This work focuses on developing an integrated workflow that combine terrestrial laser scanning, heritage building information modeling, validation methods, energy simulation, and digital heritage application. In the fact, this is come under a research project funded by JICA, Japan International Cooperation Agency. The principal investigator was just me, Hatem Mahmoud, and we had two partners, University of Johannesburg in South Africa and Kyushu University in Japan. The idea and the problem come from the big obstacles and problems to conduct on-site tests and measurements and research on the heritage buildings in Egypt and, of course, especially in Cairo. So we try to find another way to have a validated digital model for the heritage building, and then we can apply multiple applications on it in terms of utilizing green materials, utilizing a passive techniques, and even at the inspection also, and the virtual tours and digital documentation, all of them within a standardized digital workflow. So our work is not direct to the BV. However, one of the obstacles against installation of the BV, of course, in addition to the points mentioned by Professor Amar, is the heat stress in the roofs, especially in the hot climates like Egypt, and the reflected radiations that come from the roof. So if we could use or replace the roofs materials with green materials and cool roofs, so we can enhance and improve the performance of the BV if it's installed on its roof. So this is the title. Then the contents, I will start by the challenges addressed in this study, research aim and objectives, the proposed standardized workflow through three phases, and we'll introduce a case study, Beit al-Razzaz Palace in Old Cairo. Then the validated model, the BIM model, is tested through three tracks as a pilot application in terms of the inspections and the virtual tours and the energy simulation to be combined in the future with other tracks already we work on in the lab, and then the integration with the architecture lab tracks. At the beginning, one of the main problems in heritage building modeling is the lack of a standardized workflow. Often we use different tools independently. Some focus only on scanning or BIM, while others work on simulation or visualization separately. Another challenge also is integrating multiple data sources such as the laser scanning, photogrammetry, and archival drawing. The heritage building require highly accurate and validated models because they are used later for conservation simulation and decision making process. Unifying the inputs will enable us to make integrated out and work with more accurate results in case of the simulation and predicting the impact of various techniques or suggestions. Why we selected heritage building? Of course, as we mentioned, we have big difficulties to get even the permission to conduct a 3D scanning for them due to the routine and the need to approvals and permission for multiple local authorities. Also, the heritage buildings are significantly different from modern building. They usually contain irregular geometries, non-uniform wall profiles, of course, due to the long period of building the damaged surfaces, and also inaccessible spaces. Traditional documentation methods are often insufficient. Therefore, we suggested the advanced non-invasive digital technologies to achieve accurate and reproducible documentation. The main aim, as I mentioned, for this study is to develop a standardized digital workflow. We want to connect the data acquisition, validation, and the multi-objective application. The main contribution is establishing a unified multi-source acquisition methodology. Then we validate the generated HPIM, heritage building information modeling, and applying the workflow to a real heritage building case study and measure its accuracy, comparing between the site scanning and the generated BIM model. And then the validated model will be tested in multiple applications, including geometric analysis, energy simulation, and VR-based heritage documentation. The workflow consists of three major phases. Phase one, data acquisition using laser scanning. Phase two, validating the model. Finally, phase three, apply the validated model to multiple application tracks, such as damage detection, building energy simulation, and VR visualization. This is a summary for the standardized workflow that we suggested. We begin with the laser scanning from site laser scanning. So we generate a point cloud generation, then data processing and BIM model creation. We use scanning. Its range about 60 meters. It's high accuracy and can generate up to 60,000 points per second. And from this data, can create a point cloud model for the area. And then geometric validation is conducting using point-to-surface analysis, and this is a case the BIM model and the point cloud model by calculating the deviations and accuracy. And when we achieved a high accuracy model, is the model employed in 3 different tracks. The first track is for a geometry-based analysis, validation damage detection, morphological analysis. Track B, simulation-based analysis using multiple softwares and engines like Energy Plus, Design Builder, to calculate and get a quantitative data for the passive and the components used in this building and understand the system of the ventilation, a natural ventilation inside the building. And the track C for visualization and the digital heritage application, like using like Enscape and Unreal Engine. The 3 tracks, of course, employ to get an integrated multiple object assessment decision support system. This is the main aim for this suggested workflow. Now let us move to the case study that we apply our workflow. Beit al-Razzaz is one of the most significant historic urban houses. It is not only architectural heritage, but also cultural memory and social identity. The place reflects centuries of urban evolution. This is date back to the Mamluk age in Egypt, about the 15th century. It is a big palace. We selected the B zone to be our study, a pilot study. We have A as Eastern Courtyard and B Western Courtyard. We can see the Eastern entrance gate. However, due to the limitation of time and data, we selected the B zone to be our case study. The building mainly uses load-bearing masonry systems with the timber structural element. Traditional features such as are important of the architectural identity. We can here see on that 2 images, the origin architecture features, and here down is the point cloud model of the same features that created by the laser scanning. The documentation process helped us understand the spatial organization, construction stage, and functional transformation over time. These are all the drawing of the building. Also image for the place. This is an image for the scanning, site scanning using the Leica laser scanner BLK 360. And we can see here the generated, after the processing data, the generated the point cloud model. We in this case study, we selected 21 scanning positions were distributed to ensure full visibility of both interiors. It was conducted over 3 days to collect visual data. On the left, this is the 21 output for the points, and using the software of recap, Autodesk recap, we can collect the 21 position to create one model for the building. So also through this is the result on the right. It's not direct result. This is after cleaning and registration and merging of the point cloud points. The final result was a unified high data set for building geometry. So this is the phase 1 of data processing and acquisition. Next, now we have created the from using the point cloud data that generated from recap, this recap. We used a Revit to build the BIM model for the case study. The BIM model also included material information that collected from the site. Of course, using Revit, we use the manual and automating model based on reference geometry. Then the key phase and to the converting and validating is the created model and ensuring from its accuracy. The most important aspect of this work is geometric value. We compared the scan-based model with the BIM model using cloud compare software. Point to surface deviation analysis was conducted after aligning using the ICP algorithms. The achieved accuracy after multiple in the fact the first phases the accuracy wasn't too much accurate due to the vegetation. Since it's very difficult to make a BIM model for vegetation and landscape area. When we removed the vegetation and comparison for the geometrical components only, the accuracy increased and be much better. And here we can see the MSE, the mean square error was 0.68 when we make the accuracy using the vegetation area. It increased and improved double. It's about its error is increased to 0.3 instead 0.6, and the standard deviation improved from 0.3 to 0.1 after the comparison become for the geometrical components only. So after cleaning the data set and removing outliners, the mean deviation improved significantly to approximately 9.6 centimeter as maximum. Next, now after we had a validated digital model, the BIM model, we moved to the applications, the 3 tracks application. The same validated set now can support multiple disciplines and application as we will see now. The first track, as we mentioned, we have 3 tracks. The first track is the point cloud intensity data was used for damage identification. We identified the crack networks, hole bulging, plaster detachment. This track support the maintenance, planning, monitoring across times to follow up the building status. The next track is the important track is the energy simulation, where we can in the next phase to test our developed insulation sense systems, so we can estimate and predict its impacts before actually applied on the real case. So this track model was converted the HIM model. We compared the heritage-based passive design case, of course, as a test with a contemporary construction case. We changed the wall thicknesses to the contemporary systems and materials. Is it everything is okay?
All good, yeah, Professor. Yeah. We can hear you.
Okay, thank you. Yeah. Since I found some message that I thought that there's a problem. So the objective was to evaluate the environmental performance of the traditional heritage envelope. We could estimate its energy performance across the year, and to compare it with if the building is a contemporary building, we can generate some models and test some solutions and adaptation for the building using our simulation engines. In the fact, we aren't focusing primarily on the quantitative results as much as on confirming the effectiveness of the proposed flow in this comparison. This is for the track B. Then the track C, the scan data was used for immersive visualization and digital documentation. The same point cloud input can support 360-degree virtual VR applications and public engagement activities. To summarize the key findings and wrap up what we mentioned in this stage, the proposed workflow successfully integrates laser scanning, heritage building information modeling, geometric validation, simulation, application. The workflow, I think, was promising to be scalable for multidisciplinary heritage now, based on this study and experience that we got from this project, now we improved our infrastructure lab. We had multiple application for point cloud samples, whether in South Africa, also in Egypt. This has supported our PG and UG students in learning new technology. create VR tools in real heritage building, and can also scan this QR to check our other studies and other cases. Also, we engaged in activities with Kyushu and with South Africa to discuss the outputs and discuss what we can do in the future to improve the energy efficiency of the heritage buildings in especially in Egypt. Next, what we plan now, how to combine these models and test our products that we work on in our lab, and to estimate and predict its impact in heritage building. Of course, there are many aspects. It's not only the performance, also the shape, and the acceptance from the community and the local authority. However, we focus in this stage on the performance. We have four products in our lab. We have waste-based cement bricks, core roof tiles, and smart movable insulation system, and ventilated roof is employ a PCM insulation material come from food oil recycling. I will go through briefly to these products, and we hope in the future, when we combine them with the systems and estimate its impact, to share it with you, of course. This is the first one, is our movable insulation system. We designed it and we already built a prototype to test it. The idea here, this slide, it's move automatically based on the differences between indoor and outdoor temperature. It can detect the where is the heat and open and closed based on the indoor temperature to gain or release the heat from the room. This is the system, and we can see here there's eco-friendly switchable insulation. When the temperature out is bigger, it's closed automatically, and at night it reopen again to release the heat and open the inside. Also, we are now working to add a PCM to work at a heat storage and start to heat the indoor when in the winter season, like this one. You can see also some leakage from the PCM through our trials in this system. It's at night. Okay, next system, the ventilated roof. Also, we had a prototype on our in the campus roof. We have 3 cells, small cells. We make encapsulation and manufacturing to treatment of waste cooking oil to convert it to PCM and integrate this PCM in the roofs to make improve the indoor thermal comfort. The third one, and I think it's the most related to the installation with the BV on roof, is a composite super eco insulation tile. This tile is fabrication affordable waste-based thermal. It's come from the construction waste, plus terrazzo and white cement. We cast these blocks and put it on the roofs to insulate the indoor and reduce the reflected and stored heat in the roof. So if we integrate or added a PV in the future, we will compare between the roof and the roofs with the cool roof tiles, and to quantify how much it can be improve its performance when we reduce the reflected heat come from the roof at night and also through the day. And this is also, we think, it's a ventilated roof system. This is, we are now in the early stage to test and design this system. What I mentioned from our system, you can find it in our lab publications. This is some example for developing affordable cool roof and predicting a model for climate-based affordable passive envelope design in hot regions. And the experimental evaluation of thermal performance of innovative cement blocks made from construction waste and the smart movable insulation system. Finally, I would like to thank you all for I would like to acknowledge our collaborators of JICA and Kyushu and Johannesburg for their support. Thank you very, very much. Hello? Hello?
Thank you, Prof. Hatem, for your informative presentation. And we can wait for the any questions from the audience. So at the beginning, Professor Hatem?
Yes, I'm here.
Yes. Could you give us some information about the future of using artificial intelligence and robotics in improving the design, installation, and the maintenance of PV systems in the complex and sensitive heritage environments? So in case of Egypt, it's very hot weather,
Yes.
but generally in Europe, it's wet, not hot so much. So and also windy, and also the tiles suffering from the heavy ice, heavy snow for a long time during the year. So there are a lot of challenges, like leaving some water, or so mainly it is a hydrothermal challenges in the roof tiles in Europe. So we saw today that you are inventing a new tiling material, which is eco-friendly roofing, which is cool and might be smart also. So we are introducing some modeling. So could you explain more about the integration of AI intelligence, artificial intelligence, and the robotics in monitoring and improving the efficiency of and the design of the tiles?
Thank you for your question. I think the integration of the AI mainly will be in the prediction, in terms of the prediction, since like this system, the movable system, it responds after the change in the temperature. If we could read the forecasting weather and understand the actual behavior for the users, so he can respond, before the change. I think we try to utilize such systems, and maybe you are more familiar with the Arduino systems and employing IoT, and also this is in our proposal in this period, to start to learn from the users and reading the forecasting and start to respond before changing the temperature. I think this will be a very good add value for the system.
Yeah, okay, thank you for your formative response. So another question here, what are the most critical emerging research challenges and the priority area that should be addressed to advance PV integration in heritage building? I think this question can be answered by Professor Hatem, and also we can listen to the point of view from Professor Amar. So it's related to the future of the integration and the hot topic in for the heritage building. So we can this question, what are the most critical emerging research challenges and priority area that should be addressed to advance PV integration and heritage building?
I think that, of course, the energy is the top. How to improve its energy efficiency and monitoring system. And as you mentioned, also the employing and utilizing the AI systems and the early responding system to this building. As mentioned also, Professor Ammar, this is invasive. We can, many places we can even getting approval to open the building. There is many regulation against making even site tests or making any change. I think this is a big challenge and big problem. Should be revised to motivate more researchers and more labs to work on improving the performance of these buildings.
If I can add to this answer, I think first of all that the person who asked the question might be looking for a PhD thesis or postdoc. That's a good way to find a subject. Well done. I think the critical or the most challenging and appealing research in the field of adopting BIPV in historic buildings is to find another adaptability of the material. So material that can have different shapes, be installed in different positions, performance. I mean, there was a lot of progress in the field from, for example, a certain point, the shadow of a chimney used to block the whole panels in the back to produce energy. Now it's improving. It would be nice if we can find, say, bricks or stone that the surface can easily be the kind of solar panel, pieces that are not rectangular and square, with various colors and texture and to be really blend into the building without really being noticed, and the way how all this system can be connected to let's say battery, or in a way that the transition between the panels and the equipment that you need to feed electricity could be as discreet as possible. So having a new skin without having a new skin for the building.
Yeah, thank you for your informative recommendations. So I think the who asked the question now is very happy for receiving these recommendations. So okay, so at the end, we all are happy for this presentation, and appreciate your informative presentations today. One point of view from Europe and other from Middle East. So different weather, different dealing with the heritage building. So for the same aim, BV integration for the heritage building. So many challenges in material, in the monitoring, in the regulations. I think also public awareness can play a role here. So at the end, we appreciate your informative presentation today, and we thank also the audience from various places. So at the end, yeah, thank you for all.
Thank you. Thank you, Dr. Muhammad, for the invitation.
Yeah.
Thank you, Dr. Amar.
Yeah.
Thank you.
Thank you.
Thank you, everyone. Thank you
for all attendance.
Thank you, Hatem.
Yeah.
And thanks for the audience.
Before we finish the presentation, I would like to promote our sixth Solar and Wind Conference, which will be in Edinburgh again this year from June 10 to June 12, 2026. So we have now the call for full paper is not available until the end of this month. So if anyone is interested, we will be happy if you can submit your paper to our conference. And this paper, sorry, the full paper will be published in Springer again this year. Last year, the conference proceeding was already out, if you want to have a look. And we would appreciate if everyone can join this conference either online or in person. More detail will be available on our website, so you can Google that, the 6th Annual Solar Wind Power Conference at Edinburgh Napier University. And thank you so much, everyone, again, for joining our session today. We were very delighted, especially all the information presentation from the two speakers, renowned speakers that we have, Professor Amar and Professor Hatem. And hopefully we'll see you, everyone, again in Edinburgh next month. Okay?
Inshallah. Bye-bye.
Inshallah.
Bye. Yeah. Thank you.
Thank you very much.
Thank you.